Hey guys, welcome to another video. My name's Roland and I'm your tutor. In this particular video, we'll be talking about the use of prime numbers to determine whether a fraction is a terminating or a recurring decimal. Right, let's first discuss the terminating aspect. So, what does terminating actually mean? It means that the number after the decimal point comes to an end. Alright, so the likes of a half would be equal to 0.5. Let's do another one. We'd say 3 over 5 is the same as 0.6. It terminates at the 6. You've got 7 over 25, and that is equal to 0.28. Nothing else continues after the 8. These are examples of terminating decimals. Now let's do non-terminating or recurring. These are synonymous terms. Alright, so recurring decimals are decimals that do not terminate after the decimal point. So something like a third would be equal to 0.333, and that would be recurring. It would keep on going for 3 forever. So that would be written as follows, with a 0.3 and a dot on top of the 3. The same goes for the 5 over 6. We have 0.833, 3, and 3 dots continuing forever. So you've got 0.83 with a dot on top of the 3. Right, these are two lovely examples of recurring decimals. Now lastly, let's do the 3 over 7. This would give you a value of 0.42857, 0.42857, 42857 again. You see, that's what the 3 dots mean. So you'd actually generally write 0.42857 with a dot on every number. Alright, let's move forward. I haven't done the dot. There's a short method to write it, like I've done over there. But generally, you'd actually put the dot on all of the numbers. So there we have it. We've got 0.42857, 42857, and that would continue to infinity. That means it's recurring and it is non-terminating. Okay, so with that said, now that we understand what terminating and recurring is, let's discover a couple of examples. How do we discover this? Well, we actually need to do the prime factors, okay? And we go about doing this by spotting the 2 and the 5, like we did in the previous video. If you haven't actually watched these previous videos in the series, please do so. Go back and watch them because there's a lot of explanation that's very poignant and important when using your prime factors. So first we're going to decompose into prime factors the denominator. Decompose is another term that we use for finding the prime factors, or the ladder method, as I like to call it. Alright, so if we only have 2's and 5's in the denominator, then we know that the answer is actually terminating. I've color-coded this so that you don't get confused. The light blue is for terminating, and the green is for recurring or non-terminating. There we have it. So if the denominator has 2's and 5's, the answer will be terminating. It's probably good to do an example now. So let's have a look at one. Right. If it contains any other prime factor, for instance, the 3's, the 7's, the 11's, etc., then the decimal is recurring or non-terminating. Okay? We understand what recurring and non-recurring is. So let's just make a quick note. So let's make a nota bene. The reason for this is that for terminating numbers, we'll see something that has a denominator ending in a naught, meaning that it terminates. So for a terminating number, we need to actually be able to turn the denominator into a power of 10. This is done by multiplication. Okay, there's our note. It may seem a little bit vague, but the answer will make more sense when we do an example. So let's do the example 7 over 25. We leave the numerator and we'll say 7 times 4 is the same as saying 25 times 4. So you have 28 over 100 gives you 0.28. I was just converting the base or the denominator into a factor of 100 or 10. So that would be 10 squared. So that any denominator that has a power of 10, it'll always contain only a 2 and a 5. In this particular case, we see there are 2 noughts after the 1, because if it's 100, it's going to have 2 noughts. That means that you're going to have 2 times 5, and on top of the 2, you'll have a squared sign, and on top of the 5, you'll also have a squared sign. So, if the denominator contains any other prime factors, it will be impossible to turn it into a power of 10. There we go. That's another lovely note for you. Let's put a bubble around that so we don't forget. Okay, with that said, let's do another example. So if the following fractions are written as decimals, will they be terminating or non-terminating, otherwise known as recurring? There we go. Just make sure not to use a calculator. This is purely about understanding the rules regarding prime numbers and the powers of 10. Okay, so if we have the number 5 over 16, taking note that the denominator is 16, we will need to do decomposition, otherwise known as the ladder method. As follows, we'll say 16 divided by 2 gives you 8, divided by a further 2 gives you 4, divided by 2 gives you 2, and divided by 2 gives you 1. This means that 16 is equal to 2 to the power of 4. We don't have a multiple of 5. So let's actually see how we will deal with this. If we don't have the multiple of 5, we cannot say that it has a power of 10. So there are 2's and 5's for the power to be terminating. And as we saw earlier, there aren't any other prime factors, so therefore it needs to be terminating. So anything that contains a 2 and or a 5 will be terminating if it's in the denominator. Let's do 22 for instance. Now we can easily see that 22 will be 2 times 11, so we don't really need to do the ladder method for that. So we see that there's a prime number or prime factor of 11. That instantly tells us that it's non-terminating because it's not a 2 or a 5. Now let's do 4 over 125. We know that 125 through prime factoring is 5 cubed. Therefore, it's terminating because it contains a 2 or a 5. Alright, next we have 1 over 60. The prime factors are 2 squared times 3 times 5. Unfortunately, there's a 3, which is a prime factor, and therefore it's non-terminating because it's not a 2 or a 5. There we go. See how simple this rule is. So if ever you're doing the real number system and you need to classify whether something is real or non-real, or terminating or non-terminating more like, you'll do this sort of test where you look at the prime factors, and if they include 2 and 5, 2 and or 5, then the solution will be terminating. However, if there are any other prime factors other than 2 or 5, we know that it's non-terminating. So I just wanted to make a note over here saying that non-terminating and recurring are actually synonymous, meaning that they are the same thing. So if ever you hear those terms, just realize that they mean exactly the same thing. Right, let's jump to our next question. We have 3 over 120. Let's do our prime factors of 120. We'll say, well, first let's simplify. So let's say 120 divided by 3 gives you 40, and you're left with 3 divided by 3 gives you 1. So that's our simplification sorted out. What are the prime factors of 40? Let's do our ladder method. So we have 2 cubed times by 5. Therefore, terminating, as according to our rule. Our next question is 3 over 6 times by 25 to the power of 100 times by 4 to the 200. Alright, this is going to be a little bit more challenging if you're not familiar with your exponents rules, but if you know your exponents rules, great. Otherwise, go check out the videos on exponents underneath the channel. So 6 would be 2 times 3, 25 would change to 5 squared within brackets, and then you put it to the power of 100, and 4 would be 2 squared inside brackets with 200. It seems I've written 100, but it should be 200 over there. Either way, it doesn't really make any difference. All your factors are prime, therefore the answer is definitely terminating. I see that I've also cancelled the 3's, nice and easy there. And as you can see, I've written the correct answer on the right there, with 2 to the power of 400. Lovely. Therefore, this is terminating, isn't it? As long as the denominator has 2's and 5's only, you're good to go, and you know that's terminating. Right, there you have it. This answer is terminating. Easy again.